Hello guys, hope you're doing well. My name is Mahmoud Kiyasari and welcome to the very first chapter of electrical circuit. As we had a little bit of talking for the previous video, that in this kind of amazing 40 chapters journey, we are trying to give you as much as information that you can have something related to electrical circuit 1, electrical circuit 2, and a little bit of something we call as power systems, in order to you guys to have enough confidence to understand everything related to that. Obviously, when we are talking about the 40 chapters, when we are covering so many topics, it doesn't necessarily mean that we are going to talk about them in detail, but I'm trying to give you as much information as you can have in order to handle all of those things. And obviously, if I see that I do need to give you much more knowledge related to them, probably I'm going to make other kind of journeys and videos for you. So without further ado, let's just talk about it. The very first part that actually we are going to see in this 40 chapters episode is about the electrical circuit itself, but not just about the laws, not just about some kind of dive down inside solving some examples, because as we know, we have formulas, we can bang into some numbers and we get something. No. Right now, we are going to try to talk about it. We are going to talk about the current, electrons, the atomic habit, and what does that mean exactly? That when we are talking about the flow of current, what are some kind of conventional way and anything related to that. Then we are going to show you a couple of real world application of changing or some kind of interchanging or exchanging of electrons between the materials. We're talking about the materials itself, and for the next chapters we are going to see that how we can use them by some kind of formulas, and we are going to talk about the Ohm's law, which is something I like. And also we do have so many labs. I cannot wait to use that kind of oscilloscope and behind my back that is going to be used to show you guys about the AC stuff. In the meantime, I really like my small buddy over here, which is something we call as multimeter, that we are going to use in order to measure the voltage, current, and anything related to ohms. So for this chapter, probably you're not going to see my face that much because right now I have a presentation for you. It contains full and so much information. So let's just get started here. Not stuck actually. Let's talk about it without any kind of delay to completely understand what is going on. So I would really appreciate if you like, share, and comment, because this video is going to be so interesting for you. So let's talk about it. The very first thing that we have to see is the intuitive idea of what is going on around us. As we know, electricity is something that is invisible. It's not just mechanic, chemical, or any other kind of science that most of the time you have something that you can touch. Electricity is invisible. It means that we cannot see it like air, but it doesn't mean that it doesn't exist. So that guy is there, but we cannot touch it. Sometimes we can, but it's not some kind of safe if you do that, because in the future when you're dealing with high number of voltage or current, you cannot do that, and it would be so dangerous. In this chapter or in this some kind of episode, we are going to talk a little bit about that one, and let's see what is happening actually inside this invisible engine. So as I just told you, electricity is unseen power, and it's everywhere, in your phone, in your battery, in the car, in your computer, microphone. It's everywhere. It's completely inevitable. So understanding this one isn't just about academic, because we're not just talking about passing some exams. We are talking about understanding how the modern world works. And you're talking about the modern world, AI, computers, and anything. Those fantastic and phenomenal knowledge are not acceptable or cannot operate without electricity, right? So this journey will take you from the atom itself. You heard it right, folks. Today we are going to talk about atom and how actually electrons, the protons, and neutrons are going to work, to the forces that make circuits possible. We will build your mental model from the ground up. So the very first mission, as I just told you, right now we are going to explore the atoms, define the electron charge, and understand the origins of static electricity and current. And we would like to see that when we are saying current, what does actually mean? At the end of this one, or at the end of this chapter, I have some kind of expectation from you guys. The very first thing is that you guys have to completely understand the atom itself. not in very detail, but at least on that level that you guys can describe what would happen if, for instance, rub two materials together. What would happen if we are talking about different kind of materials, inductors, we are talking about isolators. What does that actually mean? So we are going to describe the atom, identify the particles responsible for electrical phenomena. Then we are going to explain what is actually the valence electron, because they are the key to a material's electrical behavior. I will talk about it. And then we have to be confident about materials classification. We do have three types of materials: conductors, insulators, and semiconductors. We will talk about all of them. And we have to find some kind of formulas in order to do what? In order to calculate the exact amount of charge based on the number of electrons. We have to know a way to calculate the precise force between any two charges using something that we call as a Coulomb's law. Then we are going to demonstrate and explain static electricity that you're using every day. And finally, we are going to apply all of those fundamental electric safety, including EST prevention, and I will let you know what does actually mean. So without further ado, let's talk about it. The very important thing that you have to know about electrical circuit is current. And obviously you heard about that. When you connect a battery to a specific load like a lamp, you see that everything is happening instantaneously. And it happened fast, in less than blink out of an eye, because electrons are somehow moving with the speed of light. We know how fast light is, right? So the idea there is not just considering the movement of electron. The idea is having the whole thing as a package. Electrons are the main responsible, are the main guys that we do have behind the movement of current. Yet we have to completely understand that what does actually mean when we say that moving electrons. What kind of electrons can move, and actually is that all of those materials can let everything happen? What is the backstory of this guy? And we are going to talk about it right now. So the cast of all matter is built from atoms. It's completely obvious. Atoms is the essence of everything, which contain three fundamental particles. Three important things that probably you all heard about that in your chemistry is about the protons. The protons are the ones, or the materials, or some kind of the parts that they do are positively charged. They do have positive and locked inside the central nucleus. Imagine that I do have the atom, and its atom is like this. It has a center, and after that it has some electrons that orbit around it. So in the center, I do have protons. Protons are stuck in here. Alongside with what? Alongside with neutrons, which they don't have any charge, and also be in the nucleus. So in the nucleus itself, we have two important particles, and neutrons and protons. Finally, we do have electrons, that these guys actually, as I just told you, are responsible for having a current in our machines. So they're negatively charged, and they're orbiting around the nucleus in different energy level. As you can see, each one of those electrons are moving through different layers. We're not going to talk about in detail number of layers and what is happening inside them. The one layer that actually is important for me is the final layer that I'm going to talk about. So about the key inside over here is that, again, the nucleus is like a heavy locked safe that you do have protons and neutrons inside of it that are stuck. They cannot move, they're just there. The electrons are like people moving in and out of the building. They can move freely at some point. Almost all electrical behavior is driven by the movement of electrons, and the very important part of some kind of electrical behavior is something that we call as current. So just before talking about the final layer and the electrons itself, we have to understand a couple of important rules that we call it as the fundamental rules of engagement. What does that mean? It is something obvious, because imagine that you do have two magnets. Each magnet has a positive and negative section, right? If you have two magnets and you're trying to connect or trying to make positive and positive close to each other, you will see that there is a force between them. It means that some kind of charge or some kind of similar charges are going to repel each other. It means that positive and positive or negative and negative cannot absorb. They're going to repel each other. That is the first important rule. The second rule is about opposite charges. It means that if you try to have two magnets, and negative and positive, if you try to make them close, you see that they're going to absorb each other, or they are going to attract each other so fast. So it means that the opposite charges are going to attract, and the same charges are going to repel. So again, about the definitions, the very first thing that we do have is about the neutral object. What does that mean? When we're talking about the neutral object, means that the charge of that guy is somehow zero. It means that the number of positive charges, which we know it as protons, are going to be as the same as the number of negative charges, which we know it as electrons. So this guy contains an equal number of protons and electrons in itself. And its net charge is going to be zero. Cool. Then we do have the charge object. This some kind of imbalance thing is happening inside of that. It means that an object becomes charged only when electrons move, right? Either that specific material is going to absorb the negative charge. It means that when we are talking about the moving of electron, we are talking about the very last layer. If your electrons are loose by just giving a little bit of energy, or even in any format, it doesn't matter. It could be heat, it could be some kind of electrical charge, it could be anything. By giving a little bit of energy, your electrons in your specific material could be loose, and these electrons are going to leave your object. At this point, an imbalance is happening. The number of protons are going to be more than number of electrons, and we say that our material is getting charged. At the same time, if I do have another material that has enough capacity in order to absorb electrons, we say that the number of electrons is getting higher and higher and getting bigger than the number of protons. And we say that we do have more number of electrons and our material or object is getting charged negative. This is the whole scenario that is happening over here. So when electrons move, either arriving or leaving, protons do not move. Again, remember that the only movable part inside your atoms are electrons. Protons and neutrons are just stuck there. So I do have a quick question for you. When you rub a balloon on your hair and it sticks, which particle moved between the two? Obviously electrons. This is the very basic test that you can see that what is happening. Just have a balloon and try to rub it on your hair. Because of this rubbing energy and because of the heat that is happening between the balloon and your hair, you do have electron movements. And these electron movements means that electrons are going to move from your sun head, which is in neutral, because right now we are as connecting to ground, the number of electrons and the number of protons inside our whole body in the total is going to be the same. So when I do have my negative is going to be get inside or getting absorbed by a balloon, that guy is going to have negative and my head is going to be positive, my head or the whole body. That's why those things are going to stuck or going to absorb each other. As we know, opposite charges are going to attract each other, right? So then we do have a very important part, and we do have a part actually is going to tell us why everything of electron movements is happening. We do have something as the valence electrons. What does that mean? As you just saw about the atoms itself, we do have the nucleus part, we do have a neutron, we do have protons, and then we do have electrons. Electrons can move in different kind of layers around my nucleus part. Important layer that we are going to talk about it is the very last layer that we call it as the valence layer. So valence layer or valence shell almost contains electrons. And these electrons for each atom is important for me. Why? Because when I'm talking about the movement of electrons, moving of these guys from one point to another, from one material to another material, these guys can actually move. Other layers are so stuck with the gravity or with the energy of the nucleus part. So it is very rare that those guys move. The only layer that we do have electrons that can actually do something is about the valence part. So at the valence section, we do have electrons, and based on the characteristic of each material, these guys have some kind of abilities. Either they can move freely or they cannot. And based on this movement, or based on the ability of movement, we are going to categorize them. So, an atom's electron personality is determined by the electrons in the outermost shell, valence shell. These are the valence electrons. So here's the pattern. The number of valence electrons is going to decide how material behave. The very first thing, 1 to 3 valence electrons. This means that at very final outer shell, we do have maybe 1 to 3 valence electrons. It means that those guys are loosely held. It means that my atom is likely to give them up. This makes it a very good conductor, like metals. What does that mean? It means that you have a very small number of electrons, 1 to 3, at the outer layer of your atom itself. And right now, your atom or your nucleus doesn't have that kind of maybe inspiration, or doesn't have that kind of energy to save them. So at this point, we say that those guys are loose, and by a little bit of energy, the heat, it could be some kind of electrical charge, it could be anything, those guys can be given to another material. So if my electrons are going to move to another material, these guy is some kind of, this atom is going to be positive. Why? On that point, the number of protons is going to be more than number of electrons, and that the specific material is going to be negative. So we like this kind of materials. We call it as conductors. You see that in metals, in some kind of the gold, the silver, in some kind of copper. That's why our wires or the cables are made of copper. Actually, it's not solely copper. It's copper, aluminum, and other kind of things, because of other subjects that you don't have to know about it right now. But at least we know those guys are going to be conductor. Then we do have 4 valence electrons. It means that right now we are in between case, and these materials can be manipulated to act as either conductors or insulators. And this is the basis of semiconductors, silicon. So what is the semiconductor again? Imagine that you have a switch, and that switch is going to give you this power to change the characteristic of your specific material. It means that if I turn that switch on, I can say that my material is going to be conductor. And if I turn that switch off, it means that I'm not letting my material to pass or some kind of to lose any electrons, and it's going to be insulator. Right now it's going to be a little bit vague for you what is happening right now, because as so far we know, the characteristic of materials is based on atoms. And can we do anything about atoms by ourselves? The actual answer is yes, and we will talk about it on the semiconductor part, about the transistor, about different MOSFET, and any kind of, right now the names are not very familiar with you, maybe some of you heard about that, but we were talking about specific structure of those materials, of those specific things that are going to be so vital for our course, and also about the world itself. Your computer, your some kind of machine, everything is based on semiconductors. Semiconductors are like small switches, that this switch is going to give you that power in order to decide that your material should be some kind of insulator or should be conductor itself. So far we know if we do have 4 electrons, like the picture that we have, in the valence layer or the valence shell, we can call them as in-between guy, or we can call them as semiconductor. So at this point, we do have another part that if we do have 5 to 8 valence electron, means that the power of my atom is so high that it can absorb so many electrons. So at this point, we say that those electrons are tightly held, and the atom wants to acquire more electrons because it has the power. So this guy is not to give them away, and this makes it a very good insulator. What does it mean by insulator? Insulator means that the electrons are highly stuck with the whole atom, that because of the power of the nucleus, they cannot move away. So what would happen if no electrons move away? We just decided that the current, or at least the flow of current, is highly related to electrons. And if I cannot move that specific electron away, or if I cannot absorb it, those guys cannot be the part of the bigger picture. Those guys cannot be a responsible or trustworthy material, as I can tell them that, hey, try to move this current, try to some kind of be in the flow. And right now we don't have definition about what is current, but at least know that the movement of electrons is the essence of current itself. So as we were just talking about materials, we had three different parts. We have conductors, insulators, and semiconductors. The conductors is just like the wire that we do have itself. What is a mechanism? It contains many free electrons, as we just told you, 1 to 3 electrons at the valence layer that are going to move easily from one atom to another. So what is the function? It's going to allow some kind of electric current to flow with a very little resistance. We don't have that much of a problem because your atoms are going to give away anything they have means electrons. Examples could be copper, aluminum, silver, and gold itself. Then we do have insulator. It means that electrons are tightly bound to their atoms and cannot move freely. So this could be plastic, rubber, glass, anything. So the function block the flow of electric current. What is the flow of electric current? Means the movement of electrons. On another hand, we do have semiconductors. It means that they can be controlled to act either as conductor or insulator. It's just like a switch, right? When you turn on the switch, this guy is going to be conductor. It's going to pass everything you have. And when the switch is off, it's going to act as an insulator and nothing can move. Nothing shall pass. The function or some kind of the foundation of all modern electronic diodes, transistor, computers, everything is based on semiconductors. Silicon, germanium, I will talk about them in detail, but you heard about that. So let's talk about a very important one. I would like you guys to have your full attention related to that because right now everything is going to be so serious. So right now we are going to talk about the current. What does it actually mean? We learned so many things, not so many things, we learned something right now, especially about the movement of electrons to talk about a very important topic, which is current. What is the definition of current? The current is the start of the circuit. You cannot say that you have a circuit or full or complete circuit without having any current. It's completely not necessary to have that. Imagine that you have a battery and you have a load, but in the meantime, you don't have any current. Either your wire has a problem, either your battery is dead. So when you don't have any current, everything would be meaningless. So we have to talk about the very fundamental thing, which is current. What is current? An electric current is the organized movement of charge in metal. This means a collective flow of free electrons. The very first things that we have to decide and has some kind of ground rules related to that is about the movement of charge. What does that mean? Whenever we say that the movement of charge, we are talking about the movement of electrons. Because so far we have decided and we are agreed that protons and neutrons, they cannot be moved. They're so stuck with their nucleus. So whenever you're talking about movement, you're talking about electrons. Those electrons can move easily from point A to point B. If I can do something like that, I can say that the electrons are moving and I can't use them because the energy is moving. Each of those electrons, they contain energy. By using that specific energy and inject it into a specific part, for example, resistor, there's some kind of the lamp, anything, I can have a full circuit and I can use it. I do have a battery, like the way that we have on the picture. I do have a load, it could be anything, and by having the electrons and the energy that those guys are going to carry by themselves, I can use the specific energy from battery for my case itself. So far we decided or we agreed. The movement of charge means the movement of electrons. So the key analogy over here is that imagine that you do have a long tube but filled with marbles. If you push one marble in, another one pops out, right? And another one, and almost it's going to happen instantly. The individual marbles is going to be considered electrons. They're going to move slowly by the signal and it's going to be so fast. It's just like the light itself. So let's look at the circuit. Imagine that I do have a battery and the battery is connected to a load. For instance, this guy is a lamp. This could be anything, by the way. When I connect that guy using wire to my lamp, obviously I see that my lamp is working. But here's the important section. What is the movement way, or what is the direction flow of my current itself? We do have two important definitions. The very first one is the electron flow. What does that mean? As I just told you, electrons are negative charges. It means that if I assume that my battery has positive and negative side, electrons don't like the negative side. They are in here, or some kind of, this guy is going to be the one that has energy in it, and electrons are inside the wire. By having negative over here, electrons would see this negative sign and they don't like it. They would like to repel that. So one electron is going to move to this way. Another electron sees the whole thing again and tries to move. Right now we agreed on two concepts. That electrons don't like the negative energy, because the negative means that they already sees the negative and they're going to repel each other. On the other hand, electrons can move from one atom to another. So electrons would move like this till the end. You see this, some kind of red arrow, it should be like this. So the red arrow means that this is the electron flow. It means that this one is physically accurate, negative to positive. On the other hand, we do have another definition that we call it as conventional current. This is the historical standard, positive to negative. So there's sometimes that you do have something in history that assume is right at the very beginning. Even though then the science came in and said that no, it's completely wrong, they just kept it as the way it was because it was a common knowledge. It is so hard again to change the common knowledge, change all of those books, and change everything. That's why we have two definitions. The right definition is the electron flow. It means that electrons are going to move from negative to positive. On another hand, we do have conventional current. The conventional current thinks that positive is the one that actually moves, or thinks that protons actually are the things that move, because in previous they assume that protons are moving. So if you consider this fact that protons are moving, you can say that protons are going to move from positive to negative, because the same scenario that we do have related to electrons can be assigned to protons if we assume hypothetically they're moving. So it means that they don't like the positive section. They don't like the positive part. So they're going to move from top to bottom. That's why we do have that kind of blue arrows. But at this point of actually the course and in all of the science, we consider the conventional current flow. It means that protons actually move. While we know protons, they don't have this ability to move. They're so stuck in the nucleus, and the only movable part is electrons. So just consider that, just agree with me about that one. The actual thing is moving is electrons, right? We know that. But right now we assume that positive particle is actually moving.